Many individuals have been involved in our field over a number of years and have witnessed firsthand its growth and the impact of what we do on research, training of young scientists and on the educational systems that prepare them. In this program we'll be talking to Professor Karin Meyer, who's been working at the Animal Genetics and Breeding Unit since 1990 full-time, but before that she worked at AGBU and also in many places around the world after she'd completed her PhD in the early 1980s. Karin, welcome.
Thank you, Bruce.
Now I'd like to begin with asking you if you would provide us with an overview of who you are, where you work and the primary focus of your work.
Okay, Bruce, maybe I should introduce you first. The interviewer is my colleague Bruce Tier, whom I've known for 31 years by now and worked more or less closely with.
Indeed.
So you want to know how I got into this?
Pretty much.
I never planned my life. I am not from a farm, but I have an interest in animals. I've always had a numerical aptitude. And when I finished school, I thought I'd become a mathematician. But I found the whole thing far too sterile. I've always been interested in solving problems, practical problems. I'm less interested in the proof of the principle. I want to use the results. The primary focus of my work, basically throughout my career, I've been working on estimation of genetic parameters, starting from my PhD in Edinburgh, on through all the jobs I've had. And I've worked in Scotland, Norway, the Netherlands, Australia, Canada. It's always been methodology of REML estimation, application thereof to data set, development of new models, that kind of thing.
Yes, indeed. In fact, in the 1980s, I recall that you used to follow the sun as much as possible and work in summer, wherever it was at the time.
That's right. I'm a wimp. I don't like cold weather.
How did you originally get interested in the field of animal breeding?
Yes, I'm one of those many girls who were interested in horses.
Right.
Not to say mad about horses. So a veterinary degree would have been an option, but unfortunately I didn't have the grades to get into vet school. So starting a degree in agriculture was a good halfway house, because the first year was just basic science training, a bit of macroeconomics and some introduction to genetics. And I still remember in semester 1 the professor walking in and showing us this, what then was a paternal half-zip model, showing us this parameter called a heritability. And I think I was hooked then. I mean, it was just fascinating how you squeeze biology into an equation.
Indeed. And that led you to go to Edinburgh in some way.
I eventually ended up in Edinburgh. I did an undergraduate degree in agriculture with which was a 4-year degree with specialization in animal science in the last 2 years, with an honours thesis in quantitative genetics.
Right.
I did get a scholarship to do the Master in Animal Breeding and Genetics in Edinburgh. So off I went to Edinburgh for a year, and I never returned to Germany.
We don't need to go there.
After I finished the Masters, Bill Hill hired me for 3 months because he had some money left on a research contract as a research assistant to work on bending. That was really a revelation. I was really thrown into cold water there. but it also gave me a taste of what science is when you're asked to think. When you don't go and search for a recipe, if you want to do something, you work it out yourself.
From first principles or something like that.
And I've always liked a challenge.
Indeed. So can you tell me a bit about your career path, if such a thing exists, and where you've worked and the sorts of different jobs you did before you probably, I guess, started with us in 1990?
Yes, so my first job was after I finished my undergraduate degree. I was a research assistant, or half-time research assistant for about, was it 4 months or 6 months? It's so long ago I can't really remember. At the Institute of Animal Breeding at the University of Göttingen. That's before I went to Edinburgh. During my time in Edinburgh, I went and worked in Norway for 4 months when Brian Kinghorn was still there.
Mm-hmm.
After I finished my PhD, I came to Armadale the first time for initially a 9 months contract. I stayed for 16 months and then started a 3-year postdoc in Edinburgh with Bill Hill, which took me 5 years to complete because I was taking leave of absence to go and work in Canada repeatedly. Did I go anywhere else?
Yeah,
No, I think it was basically Canada then, and back to Australia, of course,
yeah.
for another stint or two. And on the last stint in Australia, the then director of Output, Keith Hammond, convinced me to take on a full-time job in Armadale, which I started in 1990. Of course, it wasn't full-time in Armadale to begin with. The first
4 or 5 years.
5 years. I went back to Edinburgh for 3 months in the year. It was a nice long commute. And of course I was in Edinburgh when it was winter in Armadale.
Absolutely. Good idea. Okay. Since then, since you've been at AGBU, I mean, what sorts of work have you been involved in?
In AGBU,
Or even the...
So my main area of work before I came to AGBU was dairy cattle, dairy cattle genetics. So, but since I arrived in Armadale full-time, I've been part of the beef group. So I've analysed a lot of beef cattle data, worked on the models to analyse that kind of data, which are actually quite a lot more complicated than the dairy cattle situation. You don't quite have the volume of data, but the models are more difficult. Recording is probably not quite as good.
Definitely.
And I've also continued to work on development of methodology for REML, and that includes writing programs to do REML analyses, updating the algorithms used, updating the models which can be incorporated, that kind of thing.
Yep, thank you. How would you describe your research interests and aspirations when you first started, and how did they change with time?
Well, that's an interesting question. I don't actually think I had particularly well-defined research aspirations. If you're a graduate student starting somewhere, you're more or less given a job, and I happen to have a scholarship from the Milk Marketing Board of England and Wales to do a PhD in Scotland.
Right.
So that particular scholarship came with 27 rolls of magnetic tape. In those days, you had
12-inch,
12-inch or something rolls of magnetic tape to store your data. So that was the job, and the job was estimating genetic parameters for later lactations in dairy cattle, which immediately raised a very severe problem, namely that cows, which have a secondary and later lactation, are in part selected on the basis of their performance in the first lactation. And that was the starting point for getting into remal estimation. At that stage, there was very little on remal. There was probably Max Rothschild's thesis, which was finished just about the time I started, but wasn't yet published.
Right.
There was the original Patterson and Thompson paper from 1971. That was it.
Indeed.
So there was a lot of scope for developing your own stuff.
Well, in fact, not only was there scope, but it was almost essential.
Yes.
Yeah.
It was either that or it was sink or swim.
Right.
So how have the aspirations changed? Well, I think so. Apart from changing species, I've become more and more interested in the methodology.
Right.
And less interested in analysing data, although I must say each new data set is still interesting. It's still a challenge, and once that stops to be, I think I'll quit.
Okay, so every time you get a new data set, you need to think about what's going on in there, and not just
what's in there.
Not just take it. Indeed. So you've moved from kind of being a hired gun, if you like, to taking over and developing software, so what I'd really like to know is what were some of the major ideas and approaches that stimulated your professional growth?
Well, so yes, it was the challenge of estimating genetic parameters in a mixed model context. So it was mixed model, particularly in the early to mid 80s, the animal model got adopted.
Mm-hmm.
I think that has been a major advancement, because all of a sudden we were going from using estimation of genetic parameters. What we do is we equate covariances between relatives to their expectations. That has not changed. But initially, we just used one type of covariance at a time. We'd have the variance between sires, or the parent-offspring covariance.
Mm-hmm.
As soon as we got to a hierarchical full submodel, you would have two estimates of genetic variance. One from the sire component, one from the dam component. How do you combine the two of them and weigh them optimally? That's something remal does.
Yeah. So the animal model was able to put them all together and estimate all these things simultaneously.
Sheer magic. You can use all kinds of relationships between animals simultaneously. For a lot of areas, that does away with the need for plant experiments, which is absolutely brilliant.
Yeah, that's a very interesting point you make, because we were constrained by unbalanced data, and the mixed model kind of resolved a lot of issues, particularly in the animal model implementation. And yet there are many other places where planned experiments are still the norm. Do you think perhaps we haven't taken as much advantage, not we animal breeders, but outside animal breeding, have not made as much use of that sort of idea as they could have?
They have caught on, mostly.
Right.
Although there's still people who do an analysis of variance.
Yeah, who insist on.
And if they don't have many fixed effects to contend with, that's probably okay, but suboptimal.
Yeah, that's a good word. Okay, so I guess I'd like to ask now, who are some of the people who have had the most impact on your professional development?
Well, certainly the one person is Professor Bill Hill from Edinburgh University, who was not my supervisor for my MSc because he was on sabbatical in North Carolina for 6 months during that year. But he took me on as a PhD student, and I later worked with him as a postdoc. Very clearly, Bill has shaped my attitude to science, how to do things. Probably the biggest gift was to show me how important papers are, and writing papers is.
I'm sorry.
No, I'm not looking at you there. If, as a student or postdoc, if you wanted attention, so to speak, I'm not being facetious, you needed to give him a draft of a manuscript.
Right. Okay, that's a good idea. So just tell me a bit more about your attitude to science, which you mentioned.
Yeah, so no, let's backtrack there. I hadn't finished answering that.
Oh, sorry.
First one. But there have been other people.
Oh yeah, good point.
With supervisors and directors and bosses, so to speak. I really appreciated that most of them just let me have my head.
Did they have any option?
No, I would have taken the bit between my teeth and run anyway.
Sure.
But
you
they
know
have
that's
the
true.
confidence and the courage to let me go.
Knowing that you get and I think, to be fair, knowing that they would get a good result.
Well, I tend not to do things by halves, especially not when it comes to science. I don't have a great deal of respect for half-cooked science.
No, I don't know that.
You need to be passionate about what you're doing.
Yes.
In order to be good at it.
And what else?
And what else, of course, is a lot of elbow grease.
Thorough, yeah, perspiration, etc.
Yes. Success is what? 5% inspiration and the rest perspiration. The old adage still holds, I think.
So do you want to mention any names?
Okay, yes. So there's Keith Hammond, who's the person who first brought me to Australia, and later Hans Grasser. But I've also been influenced by colleagues, also you including, I think.
I do recall a particular subroutine that we rewrote, or you rewrote.
So you taught me some things about sparse matrix operations and linked lists, which I didn't know.
Right.
The subroutine Bruce is referring to is what was it DJN? VHF by Chuck Henderson.
That's right.
We had Dick was on sabbatical in Armadale, and he one afternoon pointed out to me saying, "Did you ever look at the code carefully?" He actually physically, he goes through and processes the rows and columns in order of the largest pivot, that's the diagonal element. But what he does is he actually physically rearranges rows and columns each time to do that.
Just going to interrupt for a minute. Back then, we would store only one triangle of a symmetric matrix, and to operate on the row and column, you kind of had to know where everything was, and it was in sparse, so everything was all this indirect addressing, which took a lot of time. So moving rows and columns about was a
standard procedure. Yeah. So all I did was taking out the moving of rows and columns.
That's right. And of course, back then we could only put 400 or 500 size in the model in the early days, and computers nowadays so different.
I don't recall how much improvement in speed it was, but it was one of the. Sometimes the little things are very useful. Yeah,
that's never give up. Basically, there's always everything is always can be made better by somebody else. Generally speaking. So anyone else you want to mention, like Colonel Sanders?
Oh yes, thank you for jogging the memory. I must still be jet lagged.
Sorry.
During my first postdoc in Armidale, I worked part-time with Professor Bernstein from the University of Guelph, which upon my return to Scotland and his return to Canada led to me spending a total of 5 summers working with him in Guelph, mostly on dairy cattle projects. We did, this is a bold claim here, we did the first complete animal model genetic evaluation for dairy cows that just happened to be on type traits rather than something useful.
Sorry, that was yeah.
I thought that was under the bill.
That was not. That was fair enough. I think it was a good comment.
And
Okay.
it's one of the few of my papers which has never been cited.
Well, that's true. We might talk about that later, actually. But okay, I'm going to ask you, what do you think was your greatest achievement, or if you've got 2, or that you can't decide between, feel free to.
Well, my greatest impact has been through my computer programs. And again, that wasn't a planned or a strategic move. It came out of having to write your own programs for what you wanted to do and other people being interested in it. So I did write a program I named DF Remel, which I released in 87.
87, was it?
And that had quite an impact on the animal breeding world. It was the first Remel package available. In those days I distributed it on floppy diskette, the 5 1/4 inch.
That's
you
right.
remember those?
I do. Ancient history now. Yes.
Well, it went through various iterations and was distributed
And you
until 2005.
used to give out the source code, as I recall.
I gave out all the source code. I didn't bother to put on copyright statements.
Yeah.
It was free for all, and I still get people asking me about it, wanting to download it, and the source code is still sitting on my website as a.
It's available. Yes.
It's available.
And following.
Following that, well, the one thing about DF Remel was that it had an interface which, at the time of writing, made sense. It asked you questions. You needed to type in answers.
Mm-hmm.
And at the time, we didn't have full screen editors. We might have had.
It's a command line interface.
Screens, but it was a line-by-line editor, so it was actually not very easy to set up a parameter file accurately. It was much easier to type in answers to questions. And once that changed, people were happier to write a parameter file. May I indulge myself in mentioning that as an honours student in my undergraduate degree, I was exposed to LSML 76,
Okay.
which was Professor Walter Harvey's program to do least squares analysis using Henderson's methods.
Yes.
And that was the first program for estimating genetic variances in animal breeding, and it had an enormous influence.
Yes, even I used it.
And it really was a fickle beast.
And very hard to drive.
Yes. And in those days, I was working with punch cards, and you needed to set up your parameter file. The numbers needed to be in exactly the right column.
No, that's right.
And if you mistyped it, you needed to sift through your deck, find the card which was wrong, and type it again. So I thought, and I must have been traumatized by that, because when I did write DF Remel, I thought, command line interface where you just type in the answers would be so much easier.
Yeah.
But that needed to be revamped, by 2000 and so forth, the hardware had changed so much it needed a total revamp. So I rewrote it all. Faster, more options, parameter file, interface, and I thought it needed a new name. And how do you name a program? So being in Australia, I thought an Australian animal, and I like wombats, so I named it Wombats. And the rumour that I named it after the computer hacker dictionary, where wombat stands for waste of money, brains and time, is totally untrue.
I'm sure. However, okay.
So that's on the computing side, and that, as I said, that's where my impact has been, and that's what I'm known for. But I've also worked out a few little tricks here and there, which I'm very proud of. One is I did some work with Mark Kirkpatrick at Texas. He's an evolutionary biologist, where he came and said, look, I've got this brilliant idea. Why don't we estimate genetic covariance matrices not at full but at reduced rank?
Yes.
And it became very obvious very quickly that all wasn't what it was supposed to be. And I did work out in the end that reduced rank estimator is not necessarily consistent, which means when you go and estimate, say you've got dimension of 10 and you estimate the first 3 principal components, you're not guaranteed to pick up 1, 2 and 3. You might pick up 1, 5 and 7.
Right.
So you need to be very careful doing that. And I eventually found an old paper of somebody having done something like that by simulation, but working that one out, I was chuffed.
So you found, and did you develop a method so you could make sure you got the first 3? So it's still open question.
It's a problem which can't be solved. It's an estimator which is not consistent, and the best you can do is develop a strategy to safeguard yourself that you're fitting enough principal components.
Yes.
Don't work your way up, work your way down.
And no, that's good. And so let's think about the development of DFREML and Wombat, and what are some of the new, well, not the new features, but it evolved over time as you added in new features. And if we think back to DFREML, where we could analyse sort of three random effect, or 4 random effects, if you like. We had direct and maternal genetic effects and a permanent environmental effect, and obviously the residual. But we've moved on a lot from there. You've added numerous features, some of which you might like to talk about.
Yes, so you just jogged my memory. So one important person, of course, has been Steve Smith,
Right.
who basically developed the derivative-free estimation, which was the basis of DFREML, and who later then came along and suggested automatic differentiation to get the derivatives of the likelihood.
Yes.
So I do need to give him credit here.
Of the likelihood as written in the derivative-free REML form. Yeah, that's right.
So, which meant we could then go back to optimization procedures which use derivatives,
yes,
which are a lot faster than the derivative method, which gets awfully slow once you have more than 2 traits.
Yeah.
So yes, with any software you get requests for new features and you bolt on bits and pieces until it becomes like a plate of spaghetti. So we've added now features for single-step prediction, GWAS.
That's right. Yeah.
Gametic imprinting, social
Social
genetic
effects.
effect. It's all in there.
And what about most recently the penalised likelihood?
Okay. So
Is that
my research interest the last few years has been, well, there's always been this controversy between frequencist and Bayesians.
About which planets they're from, yes.
And I've never really thought of myself of being either, and I think I've now landed myself firmly in the strip of no man's land between the two. My ideas are that I want to impose a penalty on the likelihood which gives me better estimates, especially for large covariance matrices. And this penalty is derived imposing a prior on some functions of the parameters estimated. And this function is targeted to reduce sampling variation. It will give you an extra little bit of bias,
Yeah.
but on average it will give you estimates which are closer to the true parameters.
Right.
I haven't actually fully implemented that in Wombat. I'm still working out what's the best way to do. And that goes back right to the beginning of my career. As I mentioned earlier, as a young student fresh out of an MSc, I had a little job for a few months with Bill Hill working on bending.
Yes.
This is basically similar to a modern implementation of bending.
And I think maybe we need to think a little bit more about that if we can in regard to why was bending required if we can go back 30 odd years, and I suppose since you're possibly one of the most experienced people on the planet in regard to estimating large numbers of parameters, I was wondering if you'd like to make any comments about how much data one needs to estimate how many parameters.
There's a lovely comment in a paper in 2010 by Bill Hill, which goes something like, I believe that most data sets in livestock or natural population are not providing us useful estimates of many genetic parameters. So we need a lot of data, especially as the number of traits we're interested in is going up and up and up.
Indeed. Okay.
But
it
has never stopped us, has it?
No, that's...
And it shouldn't.
No, that's right. And I guess if we think about your general attitude is that we're told by people who make machinery that they'll make them faster, and people who write software don't have to worry about that. And yet we're always making things faster if we can. And you've incorporated numerous different sorts of developments into the software into Wombat that does that.
Yeah, so I might just make a GPU Wombat next
week. Yes.
GPU being a graphic.
Graphical processing unit. Yeah.
Which is a kind of co-processor.
Yes, that's
allowing fairly massively parallel computations.
That's right.
But coming back to the data, it really is a chicken and egg situation.
Mm-hmm.
You need to start somewhere.
And yes, and until you've got enough machinery to do it, you can make more complicated models, and then you find out that you
need to have enough preliminary data to get some sensible answers from it,
yes,
which then show you that it is worth collecting more of the same records.
Mm-hmm. Indeed. And how does that? I mean, I suppose that's part of your attitude to science, is that you're going to pursue everything in your realm. Is that sort of?
Well, I get a bee in my bonnet. I find something new which I don't know much about, and I like to find out about it.
And when you're told you can't do that, what do you tend to do?
I don't listen. Well, not always.
No, fair enough. Okay, so
I think we need to be brave at times, or stupid, as you might want to call it.
I couldn't agree more.
Sometimes you need to bang your head against the wall.
And come up with a different way of thinking.
Occasionally you beat the wall down,
Mm.
and often you can find a way around it.
Yeah, but you need to know what the bricks are, don't you? I mean, you can't just...
And how hard your head is.
That's right. Let's just talk about the importance of publication briefly. I mean, you've published quite a lot, particularly in regard to the methodology and also in regard to the programs. What drives you so much to write so many papers?
Yes, that's a good question. Writing papers is a way of straightening out your mind, for starters. Often you find you have not understood it until you're trying to write it down. Or I
Yes.
find I have not understood it fully.
Yeah.
Very often I find that I need to do additional analysis, simulations. When I think about it hard enough to try and write it down, it really focuses
Yeah.
your mind. And as I said earlier, I was lucky enough to have a supervisor for my PhD and for my first postdoc who put an enormous emphasis on papers.
Yeah.
And,
Yeah, I think that's that shows right through.
and I don't like giving lectures or talks or things, so that's my way of communicating. I
How do
can throw a paper at somebody asks me a question, I say, go and read it.
How do you feel about interviews on camera?
Oh, terrible.
Fair enough too. Hey, listen, I was going to say, we wrote a paper together a while ago, and you taught me a lesson back then about the response to the reviewers. I don't know if you can remember that.
No, I
But-
can't. Oh dear.
No, that's right. No, but it was about they're the first people who you're trying to get to understand what you're talking about, okay? And that you should treat them. You're the first audience. It's like it's like not opening night. It's like the dress rehearsal before opening night, if you like. So I'd like to make that comment that it was a very interesting for me a very interesting way to view that process.
Well, mostly reviewers are not out to put you down.
No.
Most of the time they give you very constructive criticism.
Yeah.
And I try to reciprocate when I review papers.
Is there anything you don't like when you review papers? Well,
Well, my pet hate probably is supervisors or courses not doing their job. When you get a paper which is, clearly an inexperienced author, which had not enough guidance, the paper has not been prepared to publication standards.
Yeah.
I think that's, an insult is probably too strong a word, but it's a waste of everybody's time.
Yeah.
And as I grow older and more vicious, I'm not prepared to do their job any longer.
Fair enough. Okay, so what I'd like to now is to ask you a couple of other questions that don't relate to you so much, but now relate to what you think about the discipline. In particular, what are the key innovations, the few key innovations in the last 30 odd years that you think are most important for our discipline?
Well, certainly, as I've already talked about, the animal model, best linear prediction, and REML.
Yep.
Which gave us the tools to do our job of selecting livestock, selecting animals, or characterizing genetic inheritance in populations so much better.
Yes.
There's ample evidence that it works. We've changed our animals enormously. So that's probably the main drivers in my career. Over the last 10 years, genomics has
Swamped
firmly
us.
swamped us initially.
Yeah.
But I think it's there to stay. Initially, it came with a lot of hype, in my opinion.
Too much by the sound of it.
Yes, so I haven't developed a strong interest in it, I hate to admit.
No, I think...
We've got some way to go, but I think that's probably the next biggest thing.
Yeah,
What will come after that? Your guess is as good as mine.
well, perhaps writing our own chromosomes would be a major step.
Constructing your own chromosomes, yes.
But that's...
Well, that's what we're trying to do with personalised medicine.
Well, indeed, but we're trying to do it indirectly with artificial selection, except we get the animals to do it. Okay. I had another little question here. So what do you think? What would you be looking for if you had a postdoc working for you? What sort of qualities would you like in a postdoc?
Well, first of all, they need to put up with me as a supervisor.
Yeah.
So they need to be patient.
Very patient.
My ideal graduate student, postdoc, co-worker is somebody who's motivated.
Mm-hmm.
I might even say hungry to know. They need to be curious. They might need to want to know.
Yep.
They need to be driven to some extent and prepared to work hard. Have a passion for what they're doing.
Right.
I think that's the kind of person I could
Have
best work with.
Fair enough. Okay, a final question is, and I already know the answer to this, but the camera doesn't. How do you want to be thought of by the profession or within the profession?
Oh, for heaven's sake, Bruce. I've never wanted to portray a certain image.
Fair enough.
Think about me any way you like.
All right. Now, do you want to make any comment about this ornament we've had sitting between us for the last hour or so?
I think we talked about fat so extensively. For those of you who don't know what a wombat looks like, that's it.
Except it's a baby wombat. They're about the size of a pig, a small pig.